first question on our review is, what is the additive inverse of the absolute value of minus 8? Okay, so the absolute value of minus 8 is 8, and the additive inverse of 8 is minus 8. In number 2, we're asked to find the multiplicative inverse of 5 2/3. So first we change 5 2/3 to a fraction. All right, so we do 3 times 5 is 15, and 2 is 17, so 5 2/3 is 17 over 3. And the reciprocal is 3 over 17, so the multiplicative inverse, which is the same as the reciprocal, is 3 over 17. In number 3, we're asked to subtract minus 5 from minus 3. So when we subtract from a number, that number comes first. So minus 3 comes first. So here we're doing minus 3, and we're subtracting minus 5. So that's 2. So the answer is 2. In number 4, we're adding fractions, so we want to get a common denominator. All right, so first we factor the two denominators. 55 is 5 times 11, and 44 is 4 times 11. So the common denominator is the product of the two denominators, except we don't include the common factor twice. So we only include 11 once, so that would be 5 times 11 times 4. I'll write that 4 times 5 times 11. All right, now to change this denominator, or to change this fraction to a fraction with the common denominator 4 times 5 times 11, we have to multiply the denominator by 4. All right, so let's multiply numerator and denominator by 4. And to change the second denominator to this denominator, we have to multiply by 5. So let's do that, top and bottom by 5. So we have 12 in the first numerator and 35 in the second. And here, adding the numerators, we have 47. So that's equal to 47 divided by 220. All right, in number 5, we're evaluating minus 3 to the 4th. All right, so minus 3 to the 4th is the same as minus 3 times 3 times 3 times 3. So that exponent of 4 applies to the 3. We first apply that to the 3, and then we apply the negative sign. So that would be 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's negative 81. In number 6, we have to evaluate an expression in the order of operations. So let's just rewrite that. So we'll start with the innermost parentheses. 2 minus 10, that's negative 8. And then continuing in the parentheses, in the brackets, 4 plus negative 8 is negative 4. And now we have this product, minus 5 times minus 4, which is plus 20. So we have 3 plus 20 plus 2 times 3. And now the multiplication, 2 times 3 is 6, so that's 3 plus 20 plus 6. Which is equal to 23 plus 6, so we have 29. In number 7, we're asked which of the following are not rational. All right, so let's look at each one. 3 1/5, that can be changed to a fraction. That's rational. Here we have 2.3434, etc. This is a decimal with a repeating pattern. 3434, that's a repeating pattern, so that is rational. All right, in the next number, we have a non-terminating decimal with a pattern that's not a repeating pattern. You see 0400400004, etc. is a pattern but not a repeating pattern, so that's not rational. So that's the first number that's not rational. That would be 3.04004. Okay, that one's not rational. 45 is not a perfect square, so the square root of 45 also is not rational. Now 27 is a perfect cube. The cube root of 27 is 3, so that's an integer, and an integer is rational. And the last number is a terminating decimal. Terminating decimals are rational. So we have two numbers, these two, which are not, these two are not rational. In number 8, we're asked which of the following are rational but not integer. All right, the square root of 36 is the whole number, the integer 6. Okay, so that one is an integer. The square root of 6 is irrational, so that's not rational. Okay, here 4 3/4, that's rational and not an integer. Okay, so that's 1. All right, now 4.5678, that's also rational because it terminates and it's not an integer, it has a decimal component. The number pi is not rational, that's irrational. Here we have a decimal that does not terminate but does have a repeating pattern, so that's rational and not an integer. So let me put that down. And 16/8, well, that's equal to 2. That's an integer. So we only have three numbers that are rational and not integers. In number 9, we're asked to find the decimal representation of 7/40. So what we're going to do is we're going to divide 40 into 7. We're doing a long division. Put a decimal place here and in the quotient, and we'll put in a few zeros. Okay, now we start our division. 40 into 70 is 1 time. Okay, subtract, and we have 30. Bring down a 0. $40 goes into 307 times. Okay, 7 times 40 is 280. Subtract, and we have 20. And now bring down another 0. And 40 goes into 200 exactly 5 times. So this is our decimal representation. 0.175, that's equal to 7/40. In number 10, we're asked to find the first 3 digits of the decimal representation of 3/7. All right, so we're going to divide 7 into 3. Again, we'll just do a long division. We want 3 digits, so we'll add 3 zeros. So 7 into 30 is 4 times. 7 times 4 is 28. Bring down a 0. 7 goes into 22 times. Okay, and now bring down another 0. And 7 into 60, that's 8 times. 7 times 8 is 56. And that's as far as we're going. We just wanted the first 3 decimals. So that'll be our approximation of 3/7. In number 11, we have a expression with exponents, and we want to simplify. All right, so the first thing we do is bring this factor to the denominator and change the exponent to positive 3. Okay, so let's do that because we don't open parentheses when we have a negative exponent. All right, now this second factor stays in the numerator since it doesn't have a negative exponent. So we have 2x to the 4th, y to the minus 3, and now we change that outer exponent to a positive 3. Okay, so to continue simplifying, we want to open these parentheses. So we're going to cube everything in the parentheses. So first 2 cubed is 8. X to the 4th cubed, multiply those exponents, and we have x to the 12. And y to the minus 3 cubed, again, multiply the exponents, and we have y to the negative 9. Now we're going to bring y to the minus 3 to the denominator and change the exponent to positive 3, and bring y to the minus 9, y to the minus 3 goes to the denominator, and y to the minus 9 will bring to the numerator and change the exponent to positive 9. So let's do that, and at the same time, maybe we'll just reduce. Well, will we do that? We'll do the reducing in the next step. Let's first switch around and bring y to the 9 on top and y cubed on the bottom. And now we'll start our reducing. 4 and 8. All right, x to the 5th, x to the 12th. We're subtracting 12 minus 5. And we're left with x to the 7 in the denominator. And then 9 minus 3, we're left with y to the 6 in the numerator. Okay, so in the numerator we have y to the 6. And in the denominator we have 2 times x to the 7. In number 12 we have minus 5 x to the minus 3 divided by 2x to the 5th. We're going to start by bringing x to the minus 3 to the denominator and changing the exponent to positive 3. Leave the minus 5 in the numerator. Okay, that doesn't have a negative exponent, so we just leave it there. And just multiply x to the 5th times x cubed by adding the exponents. So we have x to the 5 plus 3, or x to the 8. And that's it. In number 13, we have a fraction in parentheses with a negative exponent. So we take the reciprocal of that fraction. Let's do that. So 3y to the 5th over minus 2x cubed, and change the exponent on the outside from negative 3 to positive 3. And now that we did that, now that we have a positive exponent outside the parentheses, we can open up the parentheses. So let's do that. So we're going to cube 3 cubed, that's 27. Y to the 5th cubed, that's y to the 5 times 3, y to the 15. Minus 2 cubed is negative 8. and x cubed cubed, that's x to the 3 times 3, x to the 9. $14 is 5 to the 0, which is 1. In number 15, we're asked to evaluate 9 to the 2,500 divided by 3 to the 4,999. In order to use our exponent rules, we need the same base. So let's first change everything to base 3. Since 9 is equal to 3 squared, we can do that. Okay, so we'll replace 9 by 3 squared. And now multiply the two exponents together. So we have 3 to the 2 times 2,500. That's 3 to the 5,000 divided by 3 to the 4,999. And now just subtract those exponents, and we get 5,000 minus 4,999 is 1, so we have 3 to the 1, or just 3.